Hello, everyone. Welcome back to our last keynote that's hosted from our stage here in the Youth Center in Belgrade. Before we get into it, I want to say that thank you again for TX Services for sponsoring the Open Day and making all of this possible. Right now, we're going to announce the final keynote. Artificial intelligence has now transcended the AI winters and has taken a firm footing in driving business value. Reaping the business benefits of investments in model and algorithms requires a clear strategy and a focus on people, processes, and governance. Organizations that can quickly build AI models and infuse them into their core business processes using enabling technologies and methodologies are the ones who will generate a huge competitive advantage and return on investment. Stuff like this and much more is the topic of our keynote, Rajeev Sharma's talk. So please, since he's joining virtually, tune him into the stage. Hi, Rajeev. Do we hear each other?
Yes, I can hear you all right.
We can hear you all right.
Can I go?
You can start.
All right. Thank you very much. Firstly, I would like to thank the organizers for giving me this opportunity. Very excited to be here.
Thank you again for sharing your knowledge.
Yeah. The topic is an interesting one, and it is derived out of my experience, leading a deep learning startup in the US, and then, building, enterprise scale algorithms, infusing them into large digital platforms at enterprise scale, and the typical challenges that I have myself experienced while leading teams in this area. Before I start, I would like to acknowledge the support from my colleagues, Bhavna Ramesh, Director of AI, in Grid Dynamics, and Naresh Shah, a senior AI engineer. They kind of, as I was brainstorming my preparation for this important talk, they gave me some very useful insights. As I said, this is based on my 7 to 8 years of experience in this area. And I wanted to start with why this is important, and how AI engineers, data scientists, or whatever the terminologies we may use, interact with the business, because it's in the end all about business. Now, what I'm showing you on the screen is actually what has happened in one of our discussions, presentations to the business of a large CPG company. And now this is a real language used by my team members, the AI ML engineers, while presenting. It said the model can predict spike on a temporal basis, but the amplitude has errors due to the variations between training and actual test data. Some of you can relate to these kind of problems. Need to review the data at aggregation level by reviewing the variations in the constituent entities that are part of the data aggregation. Then, look at the features for a given spike and examine the weights of every feature and derive some rationale for model training. And then we are trying to find ways to reduce the W main. Now, and I still remember, this was all about forecasting sales promotion, the jump in sales due to, sales promotion activity. And this was being presented. Now, you can imagine the horror on the face of business leaders who are trying to understand how does all this, the temporal spike or, the training data, how does all this would ultimately be used by them? How will this optimize their cost, and how would this help them take this platform to market quickly? And I wanted to start with this graphic real world, words. I mean, I tried to look at some of the past conversations, and and that is why I would like to base this hypothesis for this talk. And the hypothesis is that the goal of an AI ML engineer is not to build the models with the highest accuracy or the best outcome. It is, of course, important, but it is necessary but not sufficient condition. The real goal is to infuse this machine intelligence into the business processes of the enterprise and derive the business value in terms of revenue growth, cost reduction, productivity of the underlying teams, or improving customer experience and stickiness, or everything, all included, all inclusive, all of these together. Now, I'm sure every data scientist or AI engineer or ML engineer understands this intuitively. But the world that we work in tends to put you in a corner, and you tend to miss the forest, for the trees. Now, again, the fundamental differences lie in the way these two personas are built. The way the cognitive processes work. A data scientist is content-driven, focuses on the how, and is focusing on the tools, on the visualization, on the dependencies, on the libraries that he or she uses, and so on and so forth. And terms like overfitting of models, data drift, which I think Dimitri just was presenting in his MLOps talk, the concepts of reducing the errors and so on, is part of the staple diet for a data scientist. The business decision makers are not content driven; they are context driven. So while the data scientist focuses on the how, the business makers who are context driven are focused on the why. And they're more worried about the time to market, profit by industry vertical, customer stickiness based on the output of the recommendation engine, and so on and so forth. So there is a distinct difference in the cognitive processes of these two personas. And this may be a big cause for the communication gap and a big cause of distrust, or even a lot of reason for the delays in many processes that have to take place before the real AI engine is deployed in production, integrated through APIs with the enterprise platform. Now, let us look at some of the reasons why this happens, right? And like, for example, business leaders usually assume that data scientists have this ability to work with imperfect or insufficient data, look at the nans and look at the redundant data and do all the data munging without any loss in value. So if you ask a business leader, do you have enough data? I say, yeah, we collect every kind of data. As a company, it's our policy, right? If you ask the chief data officer, they will tell you, yes, we have all the data in the world. You go to the infra guy, say, yeah, we are on the best cloud platform and we have everything. Till the time, all this is true till the time the data scientist actually gets access to the data, and then the horror starts, right? And then the data scientist will struggle for months to perfect the data, but really, without really understanding, by putting this data scientist in front of an imperfect data, they will keep working on it again and again, trying different combinations, but they still may not have the context on how this will evolve when you deploy the AI model. Like example, again, Dimitri talked about data drift, talked about data missing data quality, and so on and so forth. So the whole impact on the actual business may be missed by the data scientists because all the time they were more focused on getting the data right, cleaning it, making sure that someone is making sure that the MLOps pipeline is working. But the real business context is lost. And there is a gap here, the way the whole thing is kind of plays out. The other area could be that the data scientists typically are sitting in silos and are not part of the day-to-day operations of the company. Now, your data scientist may be sitting with some chief innovation officer, or you're working with a product manager or a product designer, and some kind of in some silo though, not really with the business folks. And then what happens is the data scientists kind of lose that perspective of the use case. And then what happens is a business leader who attends a conference like this gets some idea and goes back and tells the data scientist, do you know I saw this in this conference? And do you know that we could do this and this and this? And the data scientist would scratch his head and say, yeah, but that's what I've been telling you for months, right? And so, sometimes, because they are all not engaged on a day-to-day basis, there is no crucible in which these two roles can really engage in a real, fruitful manner. The other part of the challenge is typically the language which the data scientists use. As I said, the language of a data scientist is all in terms of error reduction and data drift and improving the data quality, enriching the data, and so on and so forth, and generalizing the model rather than overfitting the model, or so on and so forth. Now, these concepts, while they are very important in the end output, the business users have a hard time understanding this, and then hence the approvals of the projects which are based on building machine intelligence kind of gets slowed down. And most of the data scientists, they can show a visualization of an output of a model. They may not have the real full stack experience to build a quick demo and integrate it with some kind of an Angular front end or a React front end through an API and show the business how this will all really come out together. So this may again this gap may lead to some kind of a delay in approvals of the projects and some back and forth between these two roles, right? The other, as I said in my earlier comment, the context versus content. The business people are focused on the context in which they operate, the time to market, competitive advantage, recommendations given to the customers on the search engine, which are more sticky, which are more relevant, which are more personalized. And the data scientist is trying to build these recommendations or train the model for a classification engine, building a CNN model or a logistic regression model. And both have their own points of view. So the qualitative and the quantitative content thrust of the data science may not fit into the wider big picture of the business guy. And then what happens is, while the data scientists may really build a solid, good recommendation engine, it may have a very narrow context, and that may open other challenges for the business. You may want to recommend a product which has a higher, like an upsell, but because of your data and the content was so narrow, your focus may have been narrow, that the recommendations are not in the best interest of the company, and there is not much of upselling happening, right? The last but an important part in this equation of the gap is the professional pride, right? We all want to show some of the complex work or how complex the kind of work we're doing, and show all those complicated graphs and analysis. And we put appendix, every slide is in the appendix to show all the extra curves and how did we get the data, how did we clean the data, what data was enriched. You'll talk about the hyperparameter tuning, the learning rates, and you'll like to show all the internal workings of the model. But what you have is a very highly impressed, but a very confused and maybe sometimes irritated business leader, who may say, what the heck, and this is not what I'm looking for. I'm trying to understand what is the business impact. And you may land up with a lot of delays, with more presentations and more discussions, and sometimes even unapproved budgets, right? Now, there is a technique on how to shape this interaction with the business leader. And most importantly, it is critical to understand that the whole job of a data scientist is not really a solo, as many of us tend to believe. It's an orchestra in the long run, in the real business sense. Because in the end, you're trying to solve a business problem. As many of the reports, you may be reading a lot of books and listening to a lot of talks. Every time they will tell you, AI engines are not about technology. Yes, the technology is what makes it work, but in the end, it's all about business. Building, infusing machine intelligence is about automating human intuition. The industrial age was aimed at automating human muscle power, right? But the age of the AI is focused on automating the human intuition, taking autonomous actions in the business operating value chain, right? So it is important to understand very early on the kind of AI machine intelligence you're building. Will the AI engine speak with you, or will it chat with you? Will it throw you a dashboard? Will it answer a question that can be asked via voice or chat, or do all of this? And then how will you show the value of the AI engine that you're building in terms of solving the business problem? And then is it about building an AI ML engine for an existing digital platform and then creating a new API which will be integrated with the existing digital platform, or are you building a cloud native intelligent platform, digital platform from scratch? These are all important discussions that a data scientist should have. And 8 out of 10 times, they don't get to do this. They work with some senior techie or senior data scientist, and it's all about algorithms and models and getting the data, deploying ML ops, but you really lose the real essence of for whom the bell tolls. And most important part is that this whole job of a data scientist is all an orchestra rather than a solo, though you may be kind of tricked into believing that this is what it is. And don't get me wrong, there are times when you have to put your head down and keep reworking. Anybody who's trained an AI engine will tell you the sweat and the toil that goes with training a model, evaluating model, integrating it on an MLOps pipeline, and then trying to get it work the way you want, and then create an automatic retraining of the model, scale the compute resources up and down on the cloud. It's easier said than done. But having said that, nobody needs to know this complexity. The real job of an AI engine is when the whole thing is very simple, when the end user uses it on a front end, on a browser, on a portal, or somebody's talking to Siri and so on and so forth. These have to be very simple, intuitive platforms. And that is the whole power of artificial intelligence and machine intelligence that the data scientists bring to life. Now, remember, there are few archetypes, right? Either any CEO is always classifying his or her risks. You're classifying the state of cancer. Is it very risky, low risky? You're classifying the credit risk worthiness of an investor. You're predicting sales forecasts. You're optimizing on cost. You're optimizing on time to market. You're doing some NLP analysis, making sense of all the text and the voice converted to text. These are some of the very common artifacts in how any CEO would run the business. So, but the use cases are infinite, and depending on the industry you are in. So just to help you understand, you may have a finite archetypes of AI model, and underneath, over these, you have supervised learning, unsupervised learning, reinforcement learning. But in the end, you're doing some of these 4 or 5 things, but the use cases are infinite. So it is the business that allows you to apply the filter of the business priority and make these use cases of infinite use cases to finite business use cases. And then when you have the business problem at hand, now you work with the product manager, with the designer of the AI in the loop experience, and then understand, okay, if this is what I need to solve, then what are the relevant data sets that will be useful? And then these data sets, what are the relevant features out of these data sets that can help me train the model which is generalizable in the business sense? And then it is the business problem that will allow you to choose the right model archetype, the algorithm, right? Is it a RNN, LSTM? Is it a CNN model? Are you going to use a neural network? Many customers will tell you that neural networks are a black box. We rather use standard statistical model so that we can deal with the coefficients. That is the world we understand from 1950. We all went to school and we all studied logistic regression, linear regression, nonlinear regression, multiple linear regression, random forest, and all those techniques. And the neural networks people have a challenge with. And then the notion of explainability of neural networks. And there's a whole world out there which you need to help the business user simplify. The business need not worry about all this. It is your job as a data scientist to help, working with the business analyst, working with the UX designer, working with the product owner, working with the product management team, working with the right stakeholders, business stakeholders, trying to understand which is, given the data sets, given the kind of data capture, given the kind of access to the data you have, what is the best algorithm archetype that you could use and then take it to the market very quickly. Now, remember, In the old paradigm, right, you took the data, you applied some business rules, and then you got some insights, which was the business intelligence world, right? We've used Cognos and all those business objects and the BI world, the data warehouse world, and the BI world, right? But that was the world of 1990s, right 2000, even till 2007, 8, till the big data boom happened, right? And the cloud happened. Till then, it was all about business intelligence, data warehouse. So you have a set of data, you have business rules, and you get insights. With the models, you have the data, and then you have some previous outcomes, which are the labels of what happened, especially in a supervised learning. And when you put this data and the outcomes together and put them in a training loop, and then apply the right loss functions, apply the right activation functions, and what you get is a trained model that represents the learning of that experience, which is enshrined in the outcomes, in the label. This is an important part, and this is where you need to involve the business folks and the analysts very early on. Now, and this is where the context setting and storytelling is important. Remember, you're dealing with the business. They know the context. They understand the context. They like to storytell. They have to present at the board meetings. They have to talk to the customers. They have to face the outside world for profit and loss and growth and costs and everything else. So you need to, in the interest of the business, as a data scientist, when you work with a team, as I said, it's an orchestra, you need to then set that context and build a small demo, right? Communicating about the demo is important. Normally, you would give a name to the demo. We would always give these attractive names to the demos. I remember when we built a demo for network, logistic route optimization, we named it Locus. So, give these attractive names to these short demos sitting somewhere in your cloud, and you should be able to, in a sandbox, and work with a full stack engineer, stitch with the API, create a small front end, and you could create, depending on what kind of model you're building, you could talk about, create a one pager, just one simple pager. The name of the fancy name of the demo, which is relevant to the use case. What is the objective of the demo? Who are the people who built this demo? I'm sure not more than 2 or 3 people. And then what are the different types of models that you're using? Is it a convolutional neural network? Is it a BERT model? Is it a RNN LSTM? Is it a random forest? Talk a little bit. Don't try to get into those details. Then tell about what kind of problem this model can solve for the business. Where all can this demo be extended to? Then talk about the metadata. How much time did it take you to train this small scale model? And then tell the business that training a small scale model and training a full scale model on full scale data may mean different things. A demo is the overfitted version of the real world, but at least they will get a sense of how the story will evolve. Tell them about the infra you need. I need a GPU, need the CPU, and leave it at that. This can be expensive. This can be energy consuming. Talk about how you're going to make this model training a green, sustainable process. We all live in the world of green, right? So you can't create an energy guzzler of a model and be proud of it, right? You need to understand that. And then talk about, on the front end, I've used Angular or I've used React just to demonstrate, because this is our environment and our company. And then give other highlights, one paragraph about the model. And then, kind of show the demo in about 5 to 10 minutes with everything that your model is supposed to do. And tell them that this is a model. The map is not the territory. This is a demo. This is a small, it's not the full scale kind of a model. So they should not go that, we've solved the problem. No, this is not the problem solution. This is how you will interact with the platform. And that's why I said, you do need the help of the business stakeholders, the BA, a product manager, an SME of the domain with the domain knowledge to back you in this demo and answer some of those business questions. Now, what are some of the ideal ways to interact, in initial workshop? Always start with a workshop. Don't just say, okay, go and go figure out, here's the data. And don't try to be in a hurry to start cranking code and start building data pipelines. And that's the last thing you should do. if you have gone to, and if you studied in an engineering school, they'll tell you that designing is the bigger part, coding is a small part. And in the whole scheme of things, your AI engine is 20 to 30% of the part. 20 to 30% of the part is the context, and the balance 60 to 70% is actually the technology, the MLOps pipeline, the data access, and the so on and so forth. So keep that focus in mind as you start building, working on an AI problem. Start with the workshop, talk to some people, and understand what is the business driver, why are you even building this, and then how will you measure that this is successful? Just because it has high accuracy doesn't mean it is successful. How will you use it? What is the kind of data you need? And just have a sense of, where does that data sit? Is it easy to get that data? Do you need permissions? Will it take time? What is the format of the data? Is it an audio file? Is it a CSV file? Is it a text file? And then who are the people you're going to work with when you need some help? How frequently will they be available to you? Who owns the data? Who owns the infra? Ultimately, whose problem is it? Who's going to give you the budget? Always start with a small joint lean workshop and prepare well for this workshop. Now, and as you have a series of these workshops, you start, getting access to the data. Never start building the model. First, understand the data through visualization. Spend some time on the patterns embedded in the data. Pair up with a business analyst or a domain expert or a product manager. Review again the business goals based on what the data is telling you. They may have asked you to solve a problem, but the data is unable to answer that question. Then you need to go back that you asked me to solve for X, but the data cannot allow me to train the machine to solve for X. Re-engage with the stakeholders if you see any counterintuitive patterns in your data. Validate the data, validate the access, validate the format. Make sure that the infra for experimentations is easy, or you understand what you need. Run your experiments, document your experiments, and then that is, once you run your experiments, you collect the right experiment sets. Make sure that you build some small demos, because ultimately all your fancy diagrams and scatter plots will mean only so much. Your immediate data science, head of data science may be happy, but that is not going to make you or them successful. The success will only come when it is integrated with the enterprise platform for business value. Now, that is when you come to a joint huddle before initiating a full scale up of your data, of your model, and using the full scale data to train your model. Now you're showing those small demos I talked about. Tell them how it is equal to the use case and how it is not equal to the use case. So they don't go with wrong assumptions. No, we have already solved the problem. We've ran into severe challenges with our reinforcement learning problem when we managed to show it for a small hub of 5 nodes and 5 by 5 hub. But when we had 50, 100 hubs, the model was a failure. And we spent 10 months building the reinforcement learning model for solving the logistics industry. So the demo, the map is not the territory. And then in the presentation, don't try to hog all the limelight and be the winner, right? Take your BAs with you, take your domain experts with you, take the UX designer with you. Make sure that you present it as a team, and then talk about the business value rather than focusing on data drift and the WMAP and so on and so forth, or the temporal drift in the data with all those complex plots. The top, if you have to take away something from this talk, remember at least these 5 key takeaways. Ultimately, what you're doing is for the business value. It's not about the implementations of the models and algorithms. The map, as I keep saying, the map is not the territory. The next piece is it's an orchestra. Make friends with other players. Build a team to help you succeed in your role. It's a tough job. There's a lot of data, but most of the data is in a state of mess. Make sure that you work with the other team members in a cross-functional manner, and then so that there is a minimum gap between the business and your work, very important work that you do. The positive impact of your work will be the highest when you actually sit along with these people in the factories, in the warehouses, in the marketing departments, in the strategy departments, rather than sitting in a different team under the chief innovation officer and somewhere in the corner and building these these models, right? And then keep practicing. Practice the art of communication of the complex work that you do with minimum jargon. You can do this when you're talking to an internal team, when you're talking to a data engineer who's building the data pipeline, when you're talking to the ML ops engineers who are going to deploy a model, talking to the infra folks for computer and storage resources, and so on and so forth, or other AI ML engineers, that's fine. But the moment you get in front of demoing, and make sure you demo to the business and not to another data scientist for the full value, then that is when you need to practice on how to talk in terms of what was the business problem you're trying to solve. Use the template, that one-pager template I talked about, and then explain to them what are you trying to solve. And last but not the least, partner with a full stack engineer. Try to create a small visualization on the front end. Work with the BA, build a nice API to your model, to your sandbox, and then try to, using simple visualization. Remember, businesses talk in terms of bar charts, pie charts, and tables, right? Every MBA teaches you how to drive. You're an Excel ninja, right? You're a PowerPoint ninja. And all those things are on a pie chart or a bar chart, histograms, and a tabulated data, right? So try to create every output of your model should kind of be in this tabulated format so that the business folks are able to understand what are you trying to present. That was the end of my talk, and I'll be open to questions. Thank you for listening to me at the end of the day. It's 5:30 or nearly 6 p.m. in Belgrade, so I really appreciate your patience and thank you for this opportunity. I'm open to questions.
Hi, Rajeev. Thank you very much for that presentation. I just want to check if there are any questions from the audience. Seems like no, but thank you again for the presentation, Rajeev. We're sorry you couldn't make it with us today to be alive, but that doesn't diminish the value of your speech and your talk.
Thank you. Bye-bye, everyone.
Bye. See ya.